Welcome to our chemistry class for today. This is our second video lesson. I hope you learned so much from our first video lesson about electron configuration. So let's have a quick recall about last week's lesson. Okay, let's start with the octet rule. Okay, octet rule refers to the tendency of the atom to prefer to have 8 electrons in their valence shell. Okay, let's try to solve. So let's have first aluminum. So what is the valence electron of aluminum? Aluminum has a valence electron of 3. So is it stable or not? Does it attain the 8 electrons? Of course not. So aluminum is not stable. How about argon? What is the valence electron? Okay, so the valence electron of argon is 8. So it is a stable atom. Last one, we have oxygen. The valence electron is 6. Again, it is not stable. Okay, I hope the octet rule is very clear to you guys. So let's simplify. If an atom has an 8 valence electron, automatic, it observes or it follows the octet rule, and it means it is stable. Okay, let's go to the next. Let's have oxidation number. It is the total number of electrons that an atom either gains or loses in order to form a chemical bond with another atom. So we have the two terms here, gains and loses. So if an atom gains an electron, it will become a negative. It will have a negative charge, and it is called an ion. If it loses an electron, it will have a positive charge, and it will become cation. Okay? So let's have this example. Aluminum again. So the valence electron is 3. So what do you think? It will gain or lose? What will be its oxidation number? It will become positive 3 because if it is 3, it has a tendency to lose electron. That's why it's positive. And how many electrons ang kailangan i-lose ni aluminum? 3. That's why the oxidation number is positive 3. Next, argon with atomic number, with a valence electron of 8. So, the oxidation is 0. Why? Because it will neither gain nor lose an electron. So, it has an oxidation number of 0. Next is oxygen with a valence electron of 6. So, 6, lose or gain? So, it will gain. So, it has a negative charge. How many? Ilan ang kailangang i-gain ni oxygen para maging stable? May 6 ka na. Ilan? Dapat 2 pa. That's why it's negative 2. Okay? So that is for the oxidation number. So let's have a quick tip on how to determine the charge based on its valence electron. If the valence electron is 1, 2, 3, automatic. That is, all of them has a positive charge. So the oxidation number is positive 1, positive 2, and positive 3 respectively. If the valence electron is 5, 6, 7, it has a negative charge, and the oxidation will become negative 3, negative 2, and negative 1. Okay, I hope this is very clear, the relationship of the valence electron to its oxidation number. Okay, another recall. We have the Lewis electron dot structure. So we can do this by using the chemical symbol of the element and using dots. So the dots here represents your valence electron. How about aluminum? The valence electron of aluminum is 3. That's why we have to put 1, 2, 3 dots around the symbol of aluminum. Another one, next is argon with a valence electron of 8. That's why we need to put 8 dots surrounding the chemical symbol of argon. Third one, you have oxygen with a valence electron of 6. 1, 2, 3, 4, 5, 6. 6 dots for its valence electron. I think this is very easy, the Lewis electron dot structure. Okay, next is... Okay, I think you're very ready for our topic for today. Our topic is about ionic bonding. So our objectives are to define what is ionic bonding and to show or to illustrate how ionic bonding occur. Okay, let's start. The question is, what is ionic bonding? Ionic bonding is a type of bond which exists between metals and non-metals. Again, how do we know if an atom or an element is a metal? If its valence electron is 1, 2, and 3. We can determine if it's a non-metal if the valence electron is 5, 6, and 7. I hope this is very clear, mga anak. Next is, it involves transferring of electrons from metals to non-metals. The keyword here is transferring of electrons. Sinong nagbibigay? Yung metal. Sinong tatanggap ng electron? Yung non-metal. Next is, so this is the differentiation between metals and non-metals. So I hope this is very clear. So you have to remember the relationship of the valence electron with the oxidation number. Nandun yan kanina sa recall natin. Okay, so I think you are ready for today's discussion. So let's start. Let us have sodium and chlorine. Let's try to determine or to show how does sodium bonds with a chlorine atom. Okay, let's start by getting their electron configuration. So I hope wala na tayong problema sa electron configuration at this time. Kasi dapat perfect na natin yan. Kasi kung mali ang ating electron configuration, sayang naman lahat. Mali na lahat yan, mga anak. So, next, after the electron configuration, we have to get the valence electron. So, the valence of sodium is 1. For chlorine, the valence electron is 7. Okay, this is very clear, I hope. After the valence, we will determine which one is metal and which one is the non-metal. Since the valence is 1, automatic it is a metal, so the oxidation number is positive 1. The valence is 7, it is non-metal, so the charge will become negative 1. Okay, next is, I will show to you the Lewis electron dot. Sodium has 1 electron, 1 valence electron. Chlorine has 7 electrons. Ano bang kailangang gawin ni sodium para maging stable siya? Mag-lose or mag-gain? Okay, tama. Dapat siyang mag-lose. Si chlorine, para mag-stable, kailangan niyang mag-gain. Ilan ang kailangang i-lose ni sodium? Isa. That's why it is positive 1. Si chlorine, kailangan niyang mag-gain ng isa. That's why it is negative 1. So this electron, this valence electron of sodium, should be transferred here kay chlorine. Nung na-transfer na siya, let's check. Stable na ba si sodium? Yes, kasi nag-lose na siya. Stable na ba si chlorine? Yes, stable na. Kasi ilan na siya? 1, 2, 3, 4, 5, 6, 7, 8. Both of them are stable. So, we can conclude that if we combine sodium and chlorine, we can form NaCl or sodium chloride. Guys, let me just tell you, paano ba natin na-derive yung sodium chloride? So, from the first element with the sodium, so pareho lang. So, sodium, sodium. But this one, the chlorine, for the non-metal part, you will change the suffix to IDE. So, chlorine will become chloride. Okay? So, that's the rule for ionic compounds. Another one is using the oxidation number. Sodium has a positive 1, chlorine has negative 1. In your mathematics, mga anak, if you have opposite charges, anong ginagawa natin? You cancel out. So, you cancel out positive 1 with negative 1. So, wala na natirang oxidation number. So, we can put them together. So, what do we form now? It is the same as NaCl, sodium chloride. So, these are the two steps or processes para ma-derive natin yung isang ionic compound. Last one. Okay, we have potassium and oxygen. We need to get the electron configuration. Next is the valence electron. Next is the oxidation number of these two elements. I hope this is very clear to you at this moment. Okay, so let's try to write the Lewis electron dot. Potassium has 1 dot because 1 valence electron. Oxygen has 6 dots because of the 6 valence electron. So, potassium has to transfer or has to lose its only 1 electron to oxygen. And oxygen needs to receive 2 electrons. Pag transfer niya yan, stable na ba si potassium? Yes. Kasi naibigay na. So, stable na siya. Si oxygen, stable na ba? Let's check. 1, 2, 3, 4, 5, 6, 7. Hindi pa. Wala pa siyang 8 electrons. So, ano kailangan natin gawin? We need to add 1 more potassium para matransfer niya yung isa niyang electron papunta kay oxygen. Pagbilangin natin yan, it is now 8. It follows now the octet rule. So, this is stable, stable, stable. We can now put them together. So, how many potassium do you see? 2. That's why it's K2. How many oxygen do you see? 1. We don't put 1 here because automatic, when there is no subscript, it means it has 1 oxygen atom. So the name is potassium and oxygen will become oxide. So it will become potassium oxide. Let's try to get the bonding using the oxidation number. Potassium has positive 1. Oxygen has negative 2. When we crisscross that, so what will happen? The oxygen here will be moved here to become the subscript of potassium. And 1 here will be transferred here to become the subscript of oxygen. It is also the same as K2O. Okay? So, which method is easier to use? Up to you. Okay, guys? Kung anong gusto nyong method of doing it in order to arrive with the formula of the ionic compounds. Okay, in our next lesson, in our Google Classroom, we will discuss further about ionic compounds and its properties. But for now, I will say bye and see you next time.